Hello students, welcome back to the classroom point. In our today's class, we shall discuss the Lewis dot structure along with the formal charge. So the only use of the Lewis dot structure is to understand the number of bonds present between the any two atoms in a polyatomic molecule. But Lewis dot structure never give information about the type of the bonds present between the molecules. It only consider the bond is always covalent. And second one is bond enthalpy it will not give any information about the bond enthalpy, bond angle and the geometry of the molecules. So it only provides the how many number of the bonds are present between the molecules. So let's begin the class now. Lewis dot representation of a molecule. So to write down the Lewis dot structure, we need to follow the certain rules. The rule number 1 here is sum the valence electrons of all the atoms in a given molecule or ion. So we need to add the valence electrons of all the atoms present in the, if molecule is given means add the number of valence electrons of all the atoms of the molecule. Sometimes polyatomic ions also will be given and add the valence electrons of all the atoms in the polyatomic ions. Next, in case of cation, subtract the positive charge from the total number of valence electrons. So we know that a cation means a positive charge and positive charge is formed by loss of the electrons. So that is the reason why in case of the positive charged ions, you count the total number of valence electrons first and subtract the whatever the positive charge is there, that much amount of the positive charge has to be subtracted from the total number of the valence electrons. And in case of anions, so we know that anion means a negative charge ion. So in case of anions, add the negative charge to the total number of valence electrons. So negative charge means anion means negative charge ions. So negative charge is formed only if extra electrons are present. So those extra electrons also we have to add to the total number of valence electrons of the molecule or molecular ion, so that we will get the final number of the valence electrons. And fourth point here is guess the structure. And try to keep 8 electrons around every atom except hydrogen, for which we need to keep only 2 electrons. That is called the duplet electronic configuration. So we have to keep only 2 electrons around the hydrogen atom, and in the case of the remaining atoms, try to arrange all these valence electrons around every atom in such a way that every atom has to get the 8 electrons. So let us take few examples here. And one more thing here is, while guessing the structure of the molecule, try to keep the less electronegative atom at the center and more electronegative atoms around the molecular ion. but this is not true all the ways. So anyhow, let's take an example here. In case of H2 molecule, we know that total number of valence electrons are 2. So that we have to arrange these 2 valence electrons between the 2 hydrogen atoms, so that these 2 electrons belong to both of these hydrogen atoms, and the structure can be written like this also. So these are the shared electron pairs between the both of these hydrogen atoms. One electron pair represents the one bond. Let us take the second example, O2 molecule. So O2 molecule means here valence electrons of every oxygen is equals to 6. So two oxygen atoms are there. So the total number of valence electrons are 12 valence electrons are there. Distribute these valence electrons around the oxygen atoms in such a way that every atom has to get the 8 electrons. So out of 12 valence electrons, I shared the 4 valence electrons. So remaining 2 electrons here, remaining 2 electrons here. So totally 4 plus 4. 8 electrons completed. Balance is 4 electrons are present, so that I can keep the 2 more electrons here and 2 more electrons here, so that around this oxygen atom 8 electrons are present, and around this oxygen atom also 8 electrons are present. So usually the shared electrons are represented by the bonds, so that we can write down the structure of this molecule like this. So here lone pair of electrons are always represented by the dots. The lone pair of electrons means these are unshared electron pairs. They are not participating in the bond formation. Let us take N2 molecule. In N2 molecule, each nitrogen atom is having the 5 valence electrons. So total number of valence electrons in N2 molecule is equals to 10. So try to share these 10 valence electrons around the nitrogen atoms. So develop the See, I am sharing the 6 electrons between the 2 nitrogen atoms, and 2 electrons here and 2 electrons here, so that every atom is getting the 8 electrons. These 6 electrons belongs to both of these nitrogens, and these 2 electrons belongs to only this nitrogen, and these 2 electrons belongs to only this nitrogen, so that it is having the 8 electrons. This one is also having the 8 electrons. So now there is a triple bond between the 2 nitrogen atoms in the N2 molecule, and every nitrogen atom is having the lone pair of electron. Next example, let us take the NH3 molecule, ammonia molecule. So in ammonia molecule, nitrogen is having the 5 valence electrons, and each hydrogen 1 electron, like that 3 hydrogen atoms are there. There are totally 8 valence electrons are present. So that let us guess this structure. We cannot keep the 8 valence electrons around the hydrogen. Hydrogen can accept only 2 electrons. So because its nearest noble gas is helium, so that hydrogen accepts only pair of electrons. That means it is always ready to get its nearest noble gas helium electronic configuration of having the only 2 electrons. So here out of 8 electrons, 6 electrons are already shared. Now try to keep 1 pair of electrons on the nitrogen, so that nitrogen has the 8 valence electrons and hydrogens are having the 2 electrons each. So the molecule can be written like this. NH4 plus ion. So in NH4 plus ion, nitrogen 5 valence electrons, 4 hydrogens, 4 electrons, positive charge. In case of cations, we have to subtract the total charge from the total number of valence electrons. So 1 positive charge is there, so that subtract that value. So answer is equals to 9 minus 1 is equals to 8 valence electrons are present. So that let us try to guess this structure. And in this case, you may ask the question that earlier I told you that while guessing the structure, try to keep the least electronegative atom at the center of the molecule. But in these cases, if you see that ammonia and ammonium and even water molecule also, more electronegative atom is present at the center of the molecule. That's why that rule can be avoided. So here Try to arrange these 8 valence electrons. Using these 8 valence electrons, I am constructing the 4 bonds with 4 nitrogen and hydrogens, so that final charge is present above the NH4 plus ion. So now its structure can be written like this. 4 bonds are present and positive charge completely belongs to the entire NH4, so that it becomes the ammonium and NH4 plus ion. Let us see the H2O molecule. Hydrogen 2 valence electrons, oxygen 6 valence electrons, again 8 valence electrons are there. So that oxygen is here. I am trying to keep the hydrogens like this. So here 2 bonds are constructed using the 8 valence electrons, 4 electrons are over. I cannot keep the remaining electrons around the hydrogen atom because hydrogens already achieved their duplet electronic configuration. So the only chance to keep the electrons is on the oxygen atom. So that oxygen is having the 2 bond pairs and 2 lone pairs. So its molecular structure can be shown like this. Remember one thing, that this Lewis dot structure never says that whether the molecules are having the bent structure or pyramidal structure or tetrahedral structure, because Lewis dot structure gives only information about the number of bonds present between the atoms in a molecule, but it never tells about what type of the bond angles or bond lengths are present. O3 molecule. 3 oxygens, every oxygen 6 valence electrons, so the total number of valence electrons are 18 valence electrons are there, so that I can keep the oxygen atoms like this. Using these 18 valence electrons, first to construct single bonds between the oxygen atoms, and don't construct here. Triple bond triangle structure is not possible, which makes the molecule unstable. So that here 4 valence electrons, here 2 valence electrons. Total number of electrons are used are 6 out of 18. So that I can keep 2 electrons here. Means around this oxygen atom 8 electrons completed. So I used the 8 electrons. Now 10 electrons are balanced. Try to keep electron pairs like this. Now here used electron pairs 1, 2, 3, 4, 5, 6, 7, 8. 8 twos are 16 electrons are used. So here out of 18, 16 electrons are used. This is getting the octet electronic configuration. This also got the octet electronic configuration. But this oxygen did not get the octet electronic configuration. So I can use the remaining 2 electrons on that particular oxygen. So that I can draw this structure as this is the ozone Lewis dot structure. So we shall see some other examples. CO3 2- carbonate ion. Total number of valence electrons. Carbon is having the 4 valence electrons. 3 oxygens, each one is 6, plus extra 2 electrons are present. So total number of electrons are, this is 18 plus 2, 20 and 4. 24 valence electrons are there. So I need to distribute these 24 valence electrons around every atom in such a way that every atom has to get the octet electronic configuration. So that to guess the structure, in this case I am keeping the less electronegative atom at the center. So remaining atoms, oxygen atoms are like this. First to construct the bonds between the atoms. Next, one more bond. So out of 24 electrons, 8 electrons are used and carbon got the octet electronic configuration, so that I cannot keep any number of electrons around the carbon either in the form of the bond pairs or in the form of the lone pairs. So I have to distribute the remaining electrons only onto the oxygen atoms, so that I can keep these 2 electron pairs here and 3 electron pairs here and 3 electron pairs here. Now you can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Means 24 electron pairs completed. 24 electrons completed. So the structure can be written like this. Here 2 electron pairs are there. Here 3 electron pairs are there. This is the carbonate ion structure. Let us try to count the nitric acid structure, HNO3. So in which total number of valence electron pairs, hydrogen 1 electron, nitrogen 5 electrons, oxygen 3 into 6, because valence is equals to 6. 18 plus 6, again 24 valence electrons are present. So guess this structure. So I am trying to keep this structure like this: nitrogen, oxygen, hydrogen, oxygen, and one more oxygen like this. So HNO3. So try to arrange the first of all lone pair of bond pair of electrons between the every atom. So single bonds are constructed. Next, you construct one more bond here. Out of 24 electron valence electron pairs, 1, 2, 3, 4, 5, 10 electron pairs completed, 10 electrons completed. And around the nitrogen atom, I cannot keep any more electrons because nitrogen got already octet electronic configuration. Around hydrogen also I cannot keep any electrons because it got the duplet electronic configuration. I have only one chance to arrange the remaining electrons as the lone pair of electrons on the oxygen atoms. So this oxygen atom will get the 2 electron pairs, and this oxygen atom also will get the 2 electron pairs in order to get the octet electronic configuration. Here also octet completed. Now let us try to keep the remaining electrons here. So total number of electrons: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 24 electrons completed. So that the structure can be written as, in the bond formation, lone pair of electrons we can represent like this. Let us take the carbon monoxide. So in carbon monoxide, carbon valence electrons are 4, oxygen valence electrons are 6, total number of valence electrons are 10. So try to keep the electrons. So out of 10, 6 electrons are used already. So here I can keep the 2 electrons and here I can keep the 2 electrons. So 6, 8 and 10 electrons. So the structure is, there is a triple bond between the carbon and oxygen in the carbon monoxide. So that again every atom is getting the 1 electron pair. So let us try to develop this structure here. For N2O, nitrogen valence electrons are 5 plus oxygen is 6. Total number of electrons are 16 are present. 10 plus 6. So now we can guess the structures like this. Just only guessing the structure. So this nitrogen got the octet electronic configuration. Out of 16 and 8 electrons are used. Now this nitrogen also got the octet electronic configuration. So that 8 plus 2, 10 electrons are used. So remaining 6 electrons are balanced. I can keep those 6 electrons on the oxygen atom. So the structure, its structure can be written like this: N triple bond N single bond oxygen. The electron pairs are adjusted like this. And even you can keep the one more structure for this N2O molecule. Developing this structure like this also possible. See, nitrogen now got the 8 electrons around it. And this nitrogen has to get the octet electronic configuration. So totally 2 lone pair of electrons and 2 bond pair of electrons. And this one also has to get the octet electronic configuration. 1, 2, 3, 4, 5, 6, 7, 8. 16 electrons completed. So its bond structure can be shown like this. Nitrogen is with 2 lone pair of electrons. Oxygen also is with 2 lone pair of electrons. So here 2 possible structures are there. If any molecule is existing in the more than 2 possible Lewis dot structures, those structures are called the resonance structures. So now we shall see among the resonance structures, which resonance structure is more stable using the concept of the formal charge. So let's begin the formal charge concept now. The main use of the formal charge, as I said earlier, whenever more than one structure, that means resonance structures are possible for a particular molecule, using the concept of formal charge, we can understand which structure is more stable and which structure is having the less energy. Those concepts can be understood from using the formal charge. But the thing is here, in case of the monoatomic ions, means single atoms if carrying the charges, for those ions we cannot apply the formal charge because they are already carrying the complete charge. Let us take an example here. If you take sodium ion, its charge is completely Na plus, single plus positive charge is present. For Mg2 plus, 2 plus is the positive charge. In O2 minus, 2 minus is the charge. In case of Cl minus, complete negative charge belongs to the chlorine atom only. So that for this type of the single atomic ions, we cannot apply the concept of the formal charge. Then where we can apply the concept of the formal charge? Concept of the formal charge is applicable only in the case of the polyatomic ions. Polyatomic molecules or ions. Because in case of the polyatomic molecules or ions, for example, if MnO4 minus is there, that minus charge belongs to which of the atom in the MnO4? So that we don't know. That has to be calculated using the Lewis dot structures. So formal charge gives the idea about what is the imaginary charge that is present on every atom in the case of the polyatomic molecule or polyatomic molecular ions. So using the concept of the Lewis dot structure, we can calculate the formal charge. So now let's try to calculate the formal charge here. Formal charge basically, it gives the imaginary charge present on an atom in a polyatomic molecule or ion. But one more thing here is, this formal charge never clearly says the charge separation between the atoms. It only says that which atom may have the charge, but it never clearly says the charge separation between the atoms. So that formal charge do not specify the charge separation between the atoms of a polyatomic molecule. Or ion. So exact charge separation it will not explain, but a possible charge present on every atom can be explained by the formal charge. And lower the formal charge, on atom, more the stability of the molecule. And some of the formal charges sum of the formal charges is always equals to the charge present on the molecule or ion. That means net charge. By adding the charges present on every atom, so that we have to get the final charge present on the every atom or molecular ion. So let us pick up some examples to understand this formal charge. So formal charge definition, this is not the definition, it is a clear explanation about the formal charge. Formal charge definition is, so the formal charge can be defined as the number of valence electrons in free atom minus number of lone pair of electrons. Number of lone pair of electrons in this sense, number of electrons in lone pairs, total number of unshared electrons. So one pair is having the 2 electrons minus number of bonds. So let us take an example here. If you take the O3 molecule, ozone molecule is not carrying any charge. So it is a neutral molecule. But after writing the Lewis dot structure and calculating the formal charge, so we will find the charges present on, imaginary charges present on certain type of the oxygen atoms. So let us take write down the structure here. It's Lewis dot structure, just now we discussed. This is the Lewis dot representation. Let us assign the number 1 to this oxygen, 2 to this oxygen, and 3 to this oxygen. And formal charge on first oxygen atom is equals to number of electrons of the free oxygen. Oxygen valence is equals to 6 minus number of unshared electrons. These 2 electrons are not shared between any 2 atoms. So that's why it is having the 2 electrons minus number of bonds. Here 3 bonds are there. So minus 3, that equals to 6 minus 5 is equals to plus 1. That means this oxygen can get the plus 1 charge. Formal charge on second oxygen atom. Valence electrons of oxygen equals to 6 minus unshared electrons, 2 plus 2, 4 are there, minus bonds 2 are there. So 6 minus 6 equals to 0. This oxygen don't have any charge. Formal charge on third oxygen atom. 6 is the valency of this oxygen. Unshared electrons 6 are present. See, 2 plus 2 plus 2. Minus 1 bond is present. 6 minus 7 is equals to minus 1. So this oxygen is carrying the plus 1 charge. This oxygen is carrying the minus 1 charge. But by summing all these values, you will get the 0. That means ozone molecule as a whole, it is not carrying any charge. But individually, they are having the certain type of the charges on oxygen atoms. Let us see the second molecule. Ammonium ion. So if you write down this ammonium ion Lewis representation structure as we have seen earlier. So this positive charge belongs to which atom here? See, all hydrogen atoms are similar. That's why one hydrogen I am finding that hydrogen formal charge. Formal charge on hydrogen atom. Valence electrons of hydrogen 1, and here no lone pair of electrons are there. One bond is there, so that equals to 0. And formal charge on nitrogen. Nitrogen valence electrons are 5 minus, here no unshared electrons are there, 0, but it is having the 4 bonds. So that 5 minus 4 is equals to plus 1. So sum of this positive charge is also giving the plus 1. This plus 1 in NH4 plus ion belongs to the nitrogen, not to the any hydrogen atom. Third one, let us take the CO3 2 minus ion, carbonate ion. So its Lewis dot's representation is this is the Lewis dot representation what we have seen. So we shall give the numbering to the oxygens 1, 2, 3 because 3 different oxygen atoms are there, and a carbon as it is only 1 carbon atom is there, so that not necessary to give the numbering. So we shall find out the formal charge on carbon atom is equals to valence electrons of carbon are 4. Carbon is not carrying any lone pair of electrons, so that 0. Carbon has the 4 bond pairs, that means 4 bonds are there, so that 0. Carbon is not having any charge. Next, formal charge on the first oxygen, this oxygen. So valence electrons of the oxygen is equals to 6. It is having the 6 unshared electrons. So 6 minus 1 bond is present. So that 1 here, so 6 minus 6 cancel, so minus 1 is present. And formal charge on the second oxygen atom. It is also having the similar structure, again 6 valence electrons, minus 6 unshared electrons are there, minus 1 bond is present, so that 6 minus 7 is equals to minus 1 charge. And third oxygen atom, 6 valence electrons for the free oxygen, 4 unshared electrons are there, 2 bonds are there. 6 minus 6 is equals to 0. Sum of this total charge is equals to minus 2, and a carbonate ion is also having the minus 2 charges. So in these minus 2 charges, there are 2 oxygen atoms are carrying the minus 1 charge each, and 1 oxygen atom is not having the any charge. So that the structure we can write down like this: C double bond O minus, and this is O minus. This is the carbonate ion structure. Next, fourth example, let us take the N2O molecule. So N2O molecule has the 2 resonance structures as I have shown you earlier. This is one resonance structure. So in this resonance structure, I will give the numbering 1 to the nitrogen. This is the second number to the nitrogen. Oxygen is only 1. So let us find out the formal charge on the first nitrogen atom. Nitrogen valency 5. It has the 2 unshared electrons. 3 bonds are there. So that 5 minus 5 is equals to 0. That means this nitrogen is not carrying any charge. What about the second nitrogen, that is center nitrogen atom? 5 valence electrons minus, unshared electrons are not there, but bonds 4 are there. This side 3, this side 1. So it is having the plus 1 charge. Oxygen, free electron, free atom valence equals to 6. 6 unshared electrons are there. 1 bond is there. So that this is having the minus 1 charge. Sum of the charges equals to 0. So its respective structure can be represented like this. Nitrogen, center nitrogen atom is having the positive charge, and oxygen is carrying the minus 1 charge. Plus and minus becomes 0. And if you see the next resonance structure of the N2O, in this case also first nitrogen, second nitrogen and oxygen. So formal charge on first nitrogen atom, if you calculate, 5 electrons free in the free atom, 4 unshared electrons are there, 2 bonds are there. So 5 minus 6 is equals to minus 1 charge. Nitrogen, second nitrogen atom, 5 electrons in the free atom, no unshared electrons, but 4 bonds are there. So 5 minus 4 is equals to plus 1. Oxygen, 6 is the valence electrons, 4 unshared electrons are there, and a 2 bond pair of electrons, that means 2 bonds are there. 6 minus 6 is equals to 0. Again, sum of the values is equals to again 0. So its respective structure can be written like this. So between these two structures, which is the most possible structure and which is the most stable structure for the N2O molecule? So while discussing the stability of the resonance structures, try to keep the negative charge on the more electronegative atom and positive charge on the less electronegative atom. In these two resonance structures, center nitrogen atom is having the plus 1 charge, that is common. So the difference is this nitrogen is having the minus 1 here and oxygen is having the minus 1 there. So keeping the negative charge on the more electronegative atom like oxygen gives stability to the molecule, because more electronegative atom can hold the maximum electron density. Hence, this structure is more stable resonance structure for the N2O molecule than this structure. So dear students, I hope you understand my class. If you really understanding my classes, please do subscribe the channel and share it with your friends. Almost all the concepts I am discussing in a clear way. That is the reason why most of my videos are too lengthy, so that you will get the clear concept about the any particular thing what I am discussing here. Unlike other videos, if 5 minutes or 2 minutes videos are there, means you will get only shortcut for that particular example, but the overall concept cannot be cleared. I am clearing the almost all the concepts in the lengthy videos. So pay attention to the entire video till the end of the video and get the knowledge. I hope you follow my videos. Thank you one and all. We shall meet in the next class.